Listen all of you. Now here one topic will discuss effect of potential on photoelectric current. Effect of potential on photoelectric current. So here first everyone listen. In y-axis, in vertical axis you check here what we have taken. Vertical axis we have taken photocurrent. Which current? Photocurrent. Photocurrent. Okay. And in x-axis what we have taken? Collector potential. Collector plate potential. So here negative x-axis it is retarding potential. What potential? Retarding potential. Yes or no? Now all of you listen carefully. Now here you have taken what? Now frequency constant. Your consideration is frequency constant here. Your frequency constant. Frequency is constant. Okay. Frequency I told. Frequency you can consider either f or nu. So that is constant. That is constant. But different intensity. What we taken another consideration here? Different intensities. Different intensities. Okay. So I1, I2, I3. This I1, I2, I3 different intensities are taken here. Yes or no? Different intensity, but frequency is what? Constant. If I do that condition and I observe photoelectric effect, what we observe? We observe that, what we observe? Okay, photocurrent in y-axis, photocurrent. And stopping your plate potential in x-axis. Then we observe that, okay, photocurrent becomes some saturation value. Get some saturation value here for different intensity, for different saturations here. Graph is constant. Graph is coming constant here. So if as intensity increases, saturation current also increases. This is called saturation current. Yes or no? And also we got for all the different intensity, okay, one negative potential is there. At that potential what is happening? Now photocurrent becoming zero. Your photocurrent what? Now negative potential minus V naught. Okay. So at that potential photocurrent is becoming what? Zero. Because remember this current is maximum. Now slowly coming to voltage axis. On the voltage axis current will be zero, right? Yes or no? So at a negative potential what is happening? Photocurrent is becoming zero. And this negative potential is called stopping potential. Why it is called stopping potential? Because it stops photocurrent. Okay, it stops a photocurrent, or it stops the movement of electron. Okay, or motion of electron. So that's why its name is given what? Stopping potential. What name is given? Stopping potential. And listen, your intensity if I check I3 intensity. Your I3 intensity is coming greater than I2, greater than I1. This one also remember. I3 intensity, different intensity. I3, I2, I3, I1, I2, I3. So I3 is greater intensity. Okay. Corresponding to that, saturation current also different. Saturation means maximum value of photoelectric current. That one will see. And listen all of you here. For all the intensity, what coming here? Only one potential, stopping potential. That means stopping potential does not depend on what? Intensity. Because for different intensity, one stopping potential. So one point you can write here, or we understood here what? Now V naught, your stopping potential. Stopping potential, what it does not depend on what? Does not depend on intensity of light. Okay. Intensity. Does not depend on intensity. Here, stopping potential does not depend on intensity. Okay, now another graph we'll do. We'll try to understand how stopping potential depends on other factor. Okay, it depends on frequency. In another graph we'll see effect of frequency. Graph we'll see. Okay, now listen all of you. So here you understood one point. Stopping potential does not depend on what? Intensity. Clear? Now some conclusion from this graph. What is the conclusion? Conclusion you try to remember here. So first one, it is found that photoelectric current increases with increase in accelerating potential. So if you are increasing the accelerating potential, photoelectric current increases. And for a certain potential of a plate A, all the emitted electrons collected by the plate A and the photoelectric current becomes maximum. And this maximum value of photoelectric current is called basically what? Saturation current. Now you can understand this graph here. In this graph, if you will see here, another graph I am doing left side, see. So see here, current increases. This is the current, no. This is your current you have taken. This is your potential. Now current increases, becomes saturated. Yes or no? So this value is called basically whatever here, suppose I max. This is called saturation current. Yes or no? So here same thing graph also you see. So what is happening? Now if you increase the accelerating potential, photocurrent increases and becomes saturated. Okay, becomes constant. That is called saturation. Becomes constant means saturation. So at maximum it attains a maximum value and becomes constant. And for different intensity, different saturation current is coming. Now next listen. So remember this definition. This maximum value of photoelectric current is called saturation current. What current? Saturation current. Tell me what is the saturation current definition? The maximum value of photoelectric current. And remember here what happens? All electrons are collected by plate A and photoelectric current becomes maximum. Next, third point, listen. Third point. So 2 points over. Next point is, for a particular frequency of incident radiation, the minimum negative, listen, the minimum negative retarding potential V naught, already I discussed. V naught is a what potential it is? Retarding, negative retarding potential. Negative potential means retarding potential. Okay, it is a deaccelerating the electron. Electron wants to move forward direction, but it is making it to move in backward direction. So that's the retarding potential given to the plate for which photocurrent stops or becomes zero. So a minimum negative potential for which photocurrent becomes zero is called cutoff or stopping potential. So definition will come here. So you remember, this is important. Okay. For stopping potential definition, remember what is the stopping potential? Remember everyone, the minimum negative potential or the minimum negative potential or retarding potential for which photocurrent becomes zero. Photoelectric effect will not happen. Are you getting or not? So that potential is called basically what? Stopping potential. So remember the definition. Pull here in third point the definition about stopping potential given. You remember this. Already we discussed in graph. In graph where is stopping potential is coming? Here. This minus V naught written. That is called stopping potential. Sometimes Vs also written or is. Now next. For a given frequency, listen all of you. For a given frequency, fourth point, the incident radiation, given frequency of incident radiation, the stopping potential is independent of intensity. I told you, stopping potential does not depend on what? Intensity. It will depend on frequency. In the next graph we'll see. So now next listen, the maximum kinetic energy of electron. See here, you had cathode here, all of you. Here cathode and here you had anode. Now electrons are coming out of this. Right? Now electron will be moving with certain velocity. Let's take this velocity is B max. Yes or no? Now what you did, you made this potential as negative. Then electron will go to A. Electron will not go to A because negative charge repels. So if anode you makes negative potential, okay, then what will happen? Now this electron will not go. That means the kinetic energy stopped by potential energy. Or kinetic energy is equal to what basically? Potential energy. So here you can write K max equal to charge into potential. K max is nothing but 1 by 2 what? 1 by 2 half m V max square into EV naught. EV naught is stopping potential. Now if I want to find velocity of electron, you can find also what is the velocity of electron. Remember V max, I am writing small v this is. So you understand carefully what is V max. What is V max? Maximum velocity of electron. Maximum velocity of electron. Okay. Maximum velocity. K max means maximum kinetic energy of photoelectrons. Electron means you write here is basically photoelectrons. Okay, clear or not? Half V m V max square equal to EV naught. If you want to find V max here, what I'll do, say everyone? If you want to find V max, what I'll do? 2 EV naught by m. Root under will be there. So root under 2 EV naught by m. E is electronic charge. E value you know. E is what? Electronic charge. What it is? 1.6 into 10 to the power minus 19 coulombs. M is what? M is mass of electron. M is what? Mass of electron. M is mass of electron. What is mass of electron? What is the mass of electron? Anybody remember? Charge of electron and mass of electron. 9.1 into 10 to the power minus 31 kg. Okay, minus 31 kg. Clear? So K max is EV naught, half mv square is coming actually EV naught. Clear? So that means stopping potential depends what? In kinetic energy. Like that relation is coming. Kinetic energy of photoelectrons. Clear? So from this graph of 5 points you understood. So now what you do? You note it down everything. Note it down. Clear? So I'll show you. You note it down. Did you understand? Any doubt is there? No doubt, right? Now can you tell me what is stopping potential? What is stopping potential? The minimum negative potential for which photocurrent is 0 or photocurrent stops. It's called basically what? Clear. That value remember, formula, the definition you remember. And graph also remember how coming. This graph for what you say? This graph for same frequency or different frequency? Same frequency, constant frequency, but different intensity. This graph will come 3 mark question they will ask in exam. You draw the graph of same frequency and different intensity. So you to do this graph perfectly. Remember, y axis is photocurrent, x axis is what? Collector plate potential. Clear? Okay. So note it down. Note it down all of you. Next, this one note it down. Next, this one. Thank you.